Okay. Are there things from that homework assignment that you'd like to go over to discuss any of that? Get some answers to? Why don't you pull that homework out if you've done it at least? So again, this was page 45. And I think we did what? 1, 2, 5, and 6. Is that right? How did they go? Okay, so. We're having a Monday morning on a Tuesday. Do you have answers for them? Would you like answers? What would you like? Did anybody get an answer for question number 1? The shortest possible time in which a bacterium can travel across a petri dish? 24 seconds? That is the right answer. That's exciting. So good work. Anybody want to go over that? We okay? Life is good. Question number 2. This one was the child pushing a shopping cart at a speed of this. How long is it going to take the child to go down an aisle with a certain length? Did you get a time for that one? Oh, that's fun. Yeah. We're being goofy again. There we go. Yeah. Cool. We okay? Sure, I was just about to ask that. Now, Isaac has been telling me all this. I just want to make sure you all are happy with this too. There's more than one person in this class. We good here, yo? Yeah? All right. Number 5. Yeah, we can take a look at number 5. Does knowing the distance between 2 objects give you enough information to locate the object? So if I tell you that the water fountain is 25 meters away from you, can you find it? Right. So what's the answer? No is the answer, right? So, or in this case, does knowing the distance between 2 objects give you enough information? It does not. You need both the distance. Oh, this is being really goofy. All of a sudden, I was just telling somebody how well this was working. It's funny how that works. So you need the distance and the direction. Welcome to our next thought process, right? And that is the idea of a vector, right? Needing both distance and direction in order to find out where we're looking for something. Yeah. And then question 6. Oh, this is the one with the bears, the brown bears in the wildlife preserve. I like this one. How'd we do on this one? Did it make sense? No? Is that a, let's go over, is that what you're saying, Stella? Okay, let's look at it. So you may want to have a book out just to look at the pictures here because I don't have them up on my computer. But it says, figure 1.9 shows a position time graph of the straight line movement of 2 brown bears in a wildlife preserve. Which bear has the greater average velocity over the entire period? So I'm going to write this down here. Number 6. The first question was the greatest velocity over the whole period. Which bear has a greater velocity at time equals 8 minutes? Oh my gosh, there's so many questions. C says, is the velocity of bear A always positive? And is the velocity of bear B ever negative? Okay. That's a lot of things. As I said before, you might want to get a book out just so you can take a look at this with us. So, greatest velocity. What does velocity mean? it's measured in meters per second, right? So if we work backwards, meters per second means that we're really looking for a distance over a time. So the greatest overall velocity. So that means we need to look at how far it goes and in how much time it goes there. Okay? So for bear A, it looks like he goes a distance of about, I feel like I need a reader to read this graph. It's hard to read, huh? Yeah. How far did he go? Like 1,500 meters? In how long? 60 minutes. Is that okay? Bear B goes a distance of 2,700 meters in 60 minutes. So which one has a greater velocity? B. Because he travels a further distance from beginning to end, right? Over the same amount of time. So bear B has our greatest velocity. Is that okay? The second question says, which one has a greater velocity at 8 minutes? How do you find the velocity from a graph? Do you remember? We did this a little bit. This is kind of how we led into this. How do you find the velocity from a graph?
We don't use the points, right?
You don't use the data points, yeah?
We use where it intersects or a halfway point.
Yeah. And you use those points. So just to relive this, for my friends that weren't here last week, we were bowling in the hallway. I went bowling with my kids this weekend. I was thinking about you guys so much, right? My little kid, right? She was doing like the granny bowling, just like you were my bowler last, right? Should have taken you with us because then you would have some bowling experience, right? So my little like almost 3-year-old was going like this, and she pushed it. And usually I was there to like help her push it, because we have to do this a lot of times. And there was one time she pushed it without me. Literally, it just kept going. Like, it was like, I was thinking like if you guys were standing there taking data, it would have been like, we stood there for, like, I kept watching it for, I feel like it was like 5 minutes. It probably wasn't quite that. It was like, come on. It was really sad. Anyway, so point of that story. Oh yeah, so we were bowling down the hallway last week. And so, Ben, you were bowling that basketball because, anyway. And then we were measuring the distance. Let's actually look at that graph because it's pretty. And we can. I think it was here. Here it is. Look at this pretty graph. You guys had much more linear data than the other class, just saying. But don't tell them I said that. I mean, it is true. You could look at the graphs. But anyway. And so we had 3 different trials that we did. And for the benefit of my friends that weren't here last week, can somebody describe for me the difference between the green trial number 7, and the blue trial? Tell me about what was going on in those trials. What was different? Go ahead.
Greater time for the green one.
Say it again.
Like greater time for the green one.
Greater time for the green one, right? It took a whole lot longer for it to get those 6 meters for the green one than it did for the blue one. So what can you tell me about the speed of the ball for the green and the blue?
It was less for the green.
It was less. It was going slower, right? Yeah. So do you remember so you can look at that either by our memory or for our friends that weren't here, if they just have to look at the graph, how can you tell just by looking at the graph that the green one was slower than the blue one? Starts with an S. Slope, right? The bigger the slope, the steeper the slope, the faster we're moving. You with me there? Okay, so this is for something that's kind of unexciting. It's just a ball rolling down the hallway. So now if we look at these bears and we look at 8 minutes, are you guys with me there? Can you look at your graph? You can't even see it on your thing because you don't have them in front of you. Will you guys all go get a book just to humor me for a second? Because we're going to look at another thing in the book in a minute anyway. So go grab a book. You can get one per pair if you want. That's fine. Okay? If you have it on your computer, that's fine too. Go, yeah. Here, will you go fill up mine too? I appreciate it. So make sure that you can see a book. Turn to page 45. Or if you have it on your computer, that's fine too. Page 45. So now we're going to look at the slope because it says which one has a greater velocity at 8 minutes. So now we're looking at it's called instantaneous velocity. Instantaneous means right now, okay? Not over this whole story of this bear like wandering through the woods. So take a look at those graphs. 8 minutes is going to be just before 10 minutes, right? And take a look at the slope of the line for bear A and the slope of the line for bear B. Which one has a steeper slope? Bear A? Bear A. Bear A has a steeper slope, so I'm just going to write myself a note here. How to find the velocity from the graph. We're going to look at the slope. The steeper the slope, oops. The faster it is. Bear A has a steeper slope. And therefore we know that he was at that point or she was going faster. Is that okay? Does that make sense? Okay. That kind of question I love that question. I would not be shocked to see something like that on a quiz on Thursday. Something like that, because I like that kind of thought process. All right, let's take a look at question C now that you've got those graphs in front of you. We have not talked about this whole idea of positive versus negative. So before we actually answer that question, I love homework because it kind of gets us to a conversation. So here's my bowling ball, right? That's the story of my bowling ball. You're the best, thanks. Is it like super full? It's like you were holding it. Awesome, thanks. The bowling ball is always going in the same direction, right? You all remember watching it? It was just going. What would it mean to have a negative velocity? What does it mean to have a negative velocity? Physically, what would it be doing? Be going backwards.
Not slowing down.
Yeah. The slowing down business is coming later, right? The slowing down and speeding up business we have not talked about yet, and we're not going to talk about for a little bit because I want to just talk about constant speed right now, okay? So this thing is going away from us. It's going in what we didn't say it, but we called that direction in the hallway positive. Who was down at the other end throwing? Was it just me that I was throwing the ball back to? If you had happened to take data of the ball going the other way, right? So like just kept going, then it would be going back like this, right? Does that make sense? This first part is positive. The second part would be a velocity that is negative because it's going backwards. So just a little note here that we might, and this might be something that you want to write down. So again, you don't have to turn those homework questions in, so you can just take notes right on them. It's kind of a nice deal, right? So if you have a positive, come on, stinker. Really? There we go. Positive velocity. If we think about that, V is equal to D over, did I use D or delta X for you guys last time? Delta X. Okay. If you want V to be positive, is time ever going to be negative? Doesn't really make sense for time to be negative. So time's not going to be negative. The only way for V to be negative is if your displacement is negative. The distance you're traveling is negative. Positive velocity means that we're moving in the positive direction. A negative velocity means that we're moving in the negative direction, or one might say that that means that we're moving backwards. Is that okay? We can take it one step further, remembering our mathematics that we know and love. This is a positive slope, right? What's that? It's a negative slope. If you were actually going to calculate that slope, I take this point and I take this point, the change in y over change in x, it goes down, right? So that's negative. The change in y, delta y, is negative over a positive. Okay? So positive velocity is also going to have a positive slope on the graph. Negative velocity is going to have a negative slope on the graph. Knowing all of that information, take a look at bear A. Bear A, the question was, is bear, excuse me, is the velocity of bear A always positive? Your answer is? Take a look at his graph. At your tables, I want you to determine the time frame over which bear A is moving negatively or has a negative velocity. What'd you guys say? What'd you find out for your time? Mira, what'd you guys find? She's like, oh, she's gonna call me. I'm sorry. What's that? Oh, okay. I'm sorry. Just one time. What's that? 10 minutes? So he's moving negative, hold on, let me write this nicely. Moving with a negative velocity for 10 minutes. Can anybody be any more, or could you be a little bit more specific? Like which 10 minutes? From 40 to 50, right? Love it. Nice job. How about bear B? Is bear B's velocity ever negative? Won't say, what'd you say? No? How do you know? Just keeps going up, right? The slope at any given point is always positive. If it's positive, it's got to be positive. Sweet. All right. We just rocked that. Questions? Is that making sense? Everybody happy? Sweet. Okay. Let's see. You can put those books away because we don't need them. Well, why don't you just close them, leave them at your table. That'll work best. I'm going to introduce you to a kind of problem that we are going to spend lots of quality time with this year. Excited? They're called ranking tasks. I love ranking tasks. Like I want a shirt that says I heart ranking tasks. I taught physics for a lot of years without ranking tasks. And actually had the book. I inherited it when I inherited my last job. And I was like, oh, this is just another thing. And so I just kind of let them go. And then, I don't know, like 5 years ago, I was at a workshop and they were like, you've got to do these. Like, you've got to try it. I was like, I'll do it. And now I'm a changed woman. Like, I love them so much because, let me tell you why I love them. I love them because it makes physics students think. and not just plug in numbers to equations. And that's what I love. The first ones I'm going to show you are going to be really straightforward, I hope. And if not, we'll just be introducing the idea in the first place. Okay. So we're going to take a look at a few like super simple ones. You don't necessarily need notes out right now, but you might need a piece of paper to kind of write some scratch ideas on. Okay. So, because you'll need to kind of like think through things and also write down your ranks so that you've got them. This is what like the kind of setup that almost all ranking tasks have. So, it gives you a setup, it gives you a picture usually, and then it asks you to rank something. That's what we're doing. So this first one says, look below, there are stacks of blocks. All of the masses in the diagram are given in terms of m, the mass of a block. So that m is like a variable, right? It's like it could be 12, it could be 100, it could be 1,000. We don't really know or care. Doesn't matter. But all the m's are the same. The question says, rank the total mass of each stack. I want you to try that, just based on what it says. See if you can come up with an order. Go ahead and do that by yourself in your brain and write it down on a piece of paper. Just like sketch it out. Give it a try. Sometimes my students think that these are like trying to trick you, and really they're not. Sometimes you have to read them carefully, but this one's pretty straightforward. Do you want to talk to each other? Talk to each other. Talk to your partner. See if they agree. Or if you're really stuck, then ask them. Rank the total mass . Think we have an answer? Ryan, how you guys doing? Maybe an answer?
We have the second half we agree on, just not the first.
Okay. Can you get me started with where you guys are?
So I put D for the greatest.
Okay.
And then A.
Okay.
And then B, C, E.
B, and then C, and then E?
Yep.
Okay. Cool. Now, thank you so much for giving me something. I love that. That's awesome. So now I'm going to ask another question, and you can answer or anybody else can answer, because part of this is that sometimes they're all greater than, and sometimes they're equal. So in this case, and I haven't looked at this one at all very carefully at all, are there any of these that are equal that we should mark as equal? So Ryan, do you want to keep talking?
A and D and C.
A and D are equal. And what other would you say?
C and E.
C and E are equal. And then B is in the middle there somewhere.
Yep.
So then we'd mark this as greater than, and we mark this as greater than. Does that make sense? Kind of the way that I'm annotating that? So D and A are greater than B, which is greater than C and E. Okay. So now I'm going to double check, because I don't know if I trust him, because we don't know each other that well yet. So if somebody else who maybe agrees with Ryan, can you tell me why you agree with him or how you solve that problem? Or else I'll pick on somebody, because I can do that too. Do you guys all agree with him?
Yes.
Yeah? Yeah? Emma, can you tell me why you agree?
Because the total mass of both D and A are the same, and of C and E, they're both the same.
Okay.
Just mixing the order.
Cool. Yeah. And so we could even take it one more step further and say, what is the total mass of A? Like 9M? The total mass of B is 6M. Then we got what, 4 and 9 and 4. Awesome. And so then if I was giving this to you, I don't know, like on a quiz or something, then I'd also ask for you to write down your reasoning. Okay? And so you would say, basically what Emma just said, right? I added the mass of each block, and the totals that I got were these, and then I could rank them. Does that make sense? Easy enough? Okay, so let me get you another one.
Is that the correct way to do it?
What do you mean?
Is D supposed to go in front of A and C supposed to go in front of D?
Like, so are you, let me make sure I understand you're asking. Could I write A is equal to D is greater than B is greater than E is equal to C? Is that what you're saying? Absolutely. Or you could write D is equal to A is greater than B is greater than C is equal to E, right? There are lots of iterations of it. As long as you have these ones equal and these ones equal and that one in between. Yeah. Generally, I will tell you that when I write them out, I write them alphabetically. So like I would write A is equal to D is greater than B is greater than C is equal to E. But that's just me because that's how my brain is. But it doesn't matter. Yeah. Yeah. All right, let's do another one. Hey, look. Oh my gosh. And then you say, this is when my students are like, you just did this one. I didn't. These are written very carefully. So what's the difference in this question as compared to the other one? Total number instead of mass. Detail oriented, right? So we're looking for the total number of blocks now. Oh, I can do that. So go ahead and do that. Just rank them up real quick. Check with your table mates. Mumble, mumble, mumble. Alex, do you guys agree back there? Hope so. He's like, I think so. What did you say, Alex? What was your answer? A. Okay. 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 All equal? All greater than? Are there any equal signs? Okay. All right. Do you guys agree with Alex? Yes? Malik says, yes, yes, I do. Awesome. All right. And then can you tell me your reasoning? That's pretty easy, right? Yeah. I always start with the easy stuff. We got to work our way up, right? Yeah. In case you didn't notice this, if all of them were 0, in this case, that doesn't make any sense. If all of them were the same, you could mark this. If you can actually not determine. Sometimes I have sometimes I have snarky students who are like, I don't know, right? If you legitimately do not have enough information, then you could do that. But then you also have to, explain why, right? What information am I missing? Yeah, that's the key there. Yeah. All right, let's do another one. Woohoo! Oh, wait, this one got all moved over. Now, did we actually do this one? Oh, no, we didn't. It's funny because these little ranking tests, they don't like to draw pictures very often. So I've got a picture that they like make 17 different questions about the same one. So it's the same question, or it's not the same question, it's the same picture. Give it a shot. You can do it. Average mass of the blocks in each stack. What does that mean? Oh. Average mass of the blocks in each stack. Of course, yes. Now, yes, you are. You don't, I mean, like, whatever. But you may, sometimes people jump to calculators when you could just like write out fractions and it makes it better. So do it if you want. I just don't want you to feel like you have to like grab onto your safety net all the time. Does that make sense? Yeah. Are you there and just waiting on me? Did you talk to your neighbors? Do you agree with them? All right, who haven't I talked to? Patience, did you guys come up with a good answer back there? Or are you still working? You still working?
Yeah, no, I'm done.
Okay. Do you want to tell me what you got?
I got A, B, D, C, E.
A, B, D, C, E. And what's equal to or not equal to?
I said A, B, D was equal.
A, B, and D are all equal. And greater than?
C, and then C, E are equal.
Okay. We agree? Joseph, you're looking uncertain or bored. I'm not sure which of those two it is. Do you want to talk about something?
No.
Are you sure?
Yeah.
Okay. Please ask if you have questions. I'm going to look at number 4, see if this one. Let's do this one. This one seems a little more relevant to you. Shown are several lines on a graph. Oh, lines. Yay. Rank the slopes of the lines. Don't be led astray. I'm going to zoom this in a little bit so you can see it a little bit better. Rank the slopes of the lines. You can talk to each other. That's fine. Have a conversation. Discuss it.
No. Oh, yeah. He is one of 4. He is the other.
That's okay. And I know what you because everybody gets stuff.
We just counted wrong.
Oh, okay. Even that, like, just let me know. I would not do that. I do not make fun of people.
I know it would be ridiculous. It would be ridiculous. This is why you got all get it wrong.
I think you're being a little too hard on yourself, my friend. Yeah, they're always crazy. Yeah.
I know what she said.
All right, how are we doing? You guys good? Alex, Malik, how you doing? You good? All right. We're going to keep cruising. Greatest to least slopes. Greatest to least slopes. Well, say what you guys say.
C, D, E,
C, D, E,
B,
B,
A.
A. Any of them equal or greater than, or how does it? All greater than? Yes? Somewhat? What are you taking issue with, Isaac? C and D are equal. C and D are equal. So rise over run, right? So we're doing up 2 over 4. Does that make sense? So let's go through it. This is what we do. This is how it rolls. Usually, when I give you ranking tasks, they are not as easy as that like first one that we did. Okay? And so usually when I do these, because I mean, let's be honest, if I was just going to give you all questions that you always got right, would that be a good use of our time? No. Okay? So usually we don't agree, which means usually we have to process, which is the whole point of this. So let's find the slope of C. Rise over run. That's 2 over 4, which is 1/2. Is that okay? Everybody happy with me there? Okay. Let's find the slope for D. One's over 4 up 2 as well, it looks like. So I think that one is also 2 over 4, which is 1/2. Does that make sense? So those guys are going to be equal. That's awesome. That's okay. All right, but those are going to definitely be the biggest we think. How do I find the slope of B? Rise over run. Let's add it up. Let's do it. So it looks like there's a point and there's a point. 1 over 4. 1 over 4 is definitely smaller than 1 over 2 or 2 over 4, so that's awesome. So I agree with that. How about E? What's true about E? Same deal, same slope. So I think that these guys are going to be equal also. What's the slope on A? 0. So you had the right order. There were just a couple that, when I first looked at this, honestly, I thought they were all different because they look different, don't they? And if you're just looking at them, and if you're just looking at like which one's the steepest and which one's the not steepest, then your eyes can play tricks on you. Part of the reason I like this process is because we have to kind of think that through, right? It's kind of like you have to kind of piece it out to get there. We try one more? Yeah. Hold on. Let's do this one. Okay, this one's got a little learning that's going to go with it. Now we're moving into position versus time graphs. So this is like our bowling balls or our basketball that was going down the hallway. The graphs below show position versus time graphs. Oh, this is for boats traveling along a little channel. The scales on both axes are the same for all the graphs. In each graph, a point is marked with a dot. Right now, I want you to just rank the velocity of the boat at each point. Okay? Does that make sense? Would you like to discuss this with your partners while you're working it through? Yeah. Why don't you have a conversation? Why don't you talk to each other? Work through this together. I'm going to zoom this in just a little bit so you can see this a little bit better. We're ranking the velocity. a good conversation to be had here.
Okay. A is equal to B is equal to
You guys doing okay? Have an answer?
No.
Oh. Get an answer. What don't you understand? What can I help you with? No, I love it. Please tell me what you don't get. So in these, so the way that the point is, it's basically, so somebody said, are we looking for the slope? Yes, you're looking for the slope. The velocity is equal to the slope of that graph.
Yeah.
The slope is the same along that whole line, so it doesn't matter what that velocity is. Does that make sense?
So yeah, so just like this.
So in physics, a lot of times the question or the challenge is really just to figure out what the question is asking, right? In this case, given a position versus time graph, if you're trying to find the velocity, what do you need to be looking for? The what? The slope, right? You're looking for the slope. So that's really what this is saying. Like we could put in parentheses, rank the slope, right? All right. So now that we know that, what's the slope for A? 1/2. Everybody okay with that? Can you see that? What's the slope for B? 1/2. All right. You see what we're doing here? Yeah? Yeah? We can kind of keep going there. Should we keep going? Yes, Ms. Garbling, let's do it. What is the slope for C? It's negative for sure, right? Negative something over something. Well, let's go. It goes all the way to here. Negative, what's that? 1, 2, 3, 4 over 3. Is that okay? Can you do that? Is that all right? Did I mess something up? I don't know. Sometimes I do.
Can you have an improper fraction?
Sure. It's physics. You can do whatever you want. I mean, like, what are we going to do with it? We're going to know that that's 1 1/3. I mean, sure. Why not? How about D? What's the slope for D? I don't know. I can't tell. It doesn't actually go into anything. How do C and D compare, friends? It's the same story, right? Literally, they just copied and pasted this thing and moved it down here. So what's the slope for D? -4/3, right? Are you okay there? How about E? What's the slope for E? 1/6. How about for F? Negative 1/6. So that's the process I would go through. Let's rank the velocities. So which one's the biggest? A and B? Which one's next biggest? E? Which one's next biggest? F? Which one's next biggest? C and D. Is that okay? Doing these calculations here is a really, really fair way to explain your reasoning. Say, I calculated the slopes, and then I ranked it by calculation. Bye-bye. Homework for tonight. Yes, it's the next set of homework. Yep, I can look it up for you.